Hello everyone, today I'll be talking about the implicit flow in our OAuth 2 series. This is a flow that is already deprecated, but it's very important for you to understand how it works, because I'm sure that there are a lot of software still using this flow, because after you implement security, it starts to be so, let's say, entangled with code that it's very difficult to replace unless it's really well architected. And from my experience, uh, software with 10 or 20 years, let's say they don't follow the modern good practices, and sometimes there was a rush to implement all this software. So sometimes we just add the technical debt, something like, okay, in the future I will fix it, but it will never be fixed because the project manager, if you are free, you can develop new features, right? So that's one of the things. So I want to teach you about this implicit flow, so if you find it, you understand it, you can explain what are the security flows that it contains, and maybe try to convince anyone, or your project manager or product owner, depending on the paradigm that you use for the management in your company, to upgrade to the most recent one that I explained in my previous video on this series. But let's go to this protocol. So the idea of this protocol was just, or this flow, the protocol itself, was to be simple. And it was really simple. With just 2 steps, you could get an access token and access to the server. Of course, there is a cost with it. But the main thing about this protocol, and that's why it was simple, its appeal was its simplicity, because tokens were delivered directly to the client via the browser URL fragment. And if you think, before moving forward on this presentation, if you pause and start to think about, try to understand the implications of an access token to be on the address of your browser. It's not that someone can look into it, because no one remembers all these numbers and digits and letters, but there are other things that you can do in a browser that later maybe you can explore information that's there. That's a tip that I give to you, but I will explain in a moment what are the security flaws here. So why was it used? First, it was quite simple to use. Then it was not possible to, even today it's not possible, or it's not recommended to store the client's secret in the browser. Of course, today you can create a kind of an hybrid approach. You have the browser, but use a backend to use the client ID and client secret to connect to authorization server, and then you receive the access token on your browser. That's one way to go. The other way is to, as you know, if you saw my previous video, is to use PKCE that allows you to use code verifiers and code challenge to replace the client secret. So it's safe to use that flow. But in the past there was the current flow, and this was the one that were used. And let's see the details. So let's start with the actors, same as before. So you have the resource owner, client application, authorization server, resource server. The resource owner, it's you, it's the person that will do the login, that will accept, say, okay, this application can do stuff in my name. So you are delegating authority to do something. That's the main purpose of OAuth 2. Then you have your client application. It can be a single page application in your browser, can be a backend, can be a device to device. There are a lot of different client applications, and we will see all of them. This is the second of a 6 videos that I will create with all the 6 possible flows in OAuth 2. Then you have the authorization server, the one that knows about all the clients and all the users, that can authenticate, that validates everything, generates tokens, and so on. And then you have the resource server, meaning the server where your client application wants to access, and based on the token generated by the authorization server, it will allow or not certain requests. Like, you can read, but you cannot write. You can read my photos. You can take the picture from my profile, and so on and so on. So the implicit flow, it's quite simple to understand, but I will explain in a moment into more detail. But looking into this diagram, so you are the user, you go into a browser, client application, single page application, for instance, and you access. And there are a lot of different ways to check if you are authenticated or not. Imagine that it's a cookie. So the application decides, okay, you're not authenticated. I need for you to authenticate because I need an access token for later access an API or other resource. So they redirect you to your authorization server. Let's imagine that it's Google, for some reason. So you provide the client ID, the redirect, so the Google will redirect to your server that will, of course, redirect to your browser, but in this case, it will redirect directly to your browser. You provide the scopes, meaning the permissions that you want your client to have to access the resource. The response type, you want a token, and you will, on the response type, you want an ID token, for instance, if you need ID information, or you just want just a regular token. So it was possible to receive both tokens, an access token and an ID token, like today when you use OpenID. So the one it's for the client to access resources, and the ID token it's to validate the user and to get information about user. So at the end of the day, you can think about the access token. It's a kind of a token for the client, and ID token it's for the resource owner. You can see it somehow like that. So then it will be the login, of course. You provide your credentials, the authorization server. Okay, great. It will ask you, hey, this guy is asking for these scopes. Do you accept or not? Yes, I accept. You can read my profile photo, my email, and things like that. It grants you permission. And now the authorization server just redirects using the address of your browser the access token directly. If you saw my previous video, you know that there is an intermediate step here on the current one, which is to use a code. It will give you a code, then you send the code to the authorization server, and then the authorization server will provide you access token, but not on the address, using a JSON body on the response. So, and there are a lot of the advantages on that I'll explain in a moment. So the first big change here was that in this deprecated flow, you can see that you after you authenticate, you receive directly the access token. There is no middle step here. Now you extract the token from the URL, for instance, using JavaScript, and then you start to use this token to access the resource server. It's quite simple, but it's quite dangerous, as we see in a moment. So let's go into more detail if you want to follow step by step what happens. So user access your application, it redirects auto authorization. Let's say that it's Google, for instance. This request, it provides the client ID because it's mandatory on the OAuth 2, the redirect ID, meaning where the authorization server should respond with the ID, with the access token, the scope, the permissions that you want to request, and the state just to protect for the cross-site forgery here. And crucial response type token for pure OAuth, or if you want also the token for a user, you have to provide on the response type ID token and token, so you can receive both if you want a kind of open ID and access token. This tells the auth server to return tokens directly. There is no intermediary step, as I said previously, with a code, but you can see my previous video if you want to understand better all these details. So your first step will be a get to, let's say, authorize on Google. Response token, you say that I want a token here. Client ID, of course, you need it to redirect your application that with a callback. That's where you will receive the URL with access token, not the JSON. It's on the address. Now the scope, the read profile, and the state to protect against cross-site. Okay, it's very similar to the previous one, but now it's where things start to change. First, you use the authentication and consent, meaning, okay, this is my username, my password, and I accept the scopes, similar to the other one. But now you can see from the response, and this is the problematic part, from the Google, let's say the authorization server. It's not that Google is guilty about this. This is of course, the wrong version to use. Today we have improved. I'm just using Google as an example, authorization server. So the critical difference, instead of a code, if you see my previous video or you understand the main flow of the OAuth 2, you know that now on this step, the client will send a code to the Google again, and Google will take this code and will reply to you with the tokens that you request. In this case, no, there is no code. It's just direct. The Google just respond to you, okay, here your token on the address of your browser, not as a JSON content. Now you have the token type, it's a bearer, expires, the scope, and the state. And now it's you that you have to extract the access token, for instance, using client-side JavaScript. It's never a good idea when you have to use JavaScript to go outside of your application to the address of your browser or collect cookies or something like that. it's never a good idea from the security point of view. And now, since you have the token, you can access protected resource, and you can go to the research server and validate the token if you will. So let's see now the difference between the current one and this one that I'm explaining. So when using OIDC with implicit flow, the ID tokens also return directly on the URL, which is a problem because now you have both tokens on the URL fragment. And again, if you want to pause, or maybe by now you understand what are the big problem of this deprecated flow. It's the critical security vulnerability. It's that it's presented due to the approach of using the address. So the first one and most principal one, it is this one, which is the token leakage via browser history. When you are navigating in a browser, all the address that you click, unless you disable it, it's in history. So later, someone if can access your browser or even other applications to the history of your browser, he can see the tokens. They are valid, and if they are still valid, they can be used and as an attacks against your resources. It's a very serious thing here. And if you have received like in the current, not with this flow, but the current one, you understand that they are not in the address. They are adjacent, and it will be the responsibility of your application to store wherever they want, in a cookie or something like that, but not in the history. History, it's human readable. It's quite easy to look into it. There are even a lot of extensions that can explore the history of a browser. So it was a really big security issue. So browser history, web server logs, proxy server logs, every component in architecture that can look into the address will contain in some probability the tokens generated. So it's not a good thing. Okay. And there are another thing, which is the lack of sender constraint. So there is no proof that the party receiving the token, it's the same party that initiated the request. And this is addressed with the current flow, the most recent one, that it's more safe because there is a middle step, second step, where a code is generated on the client that will be sent to the authorization server, and later the authorization server will check the code and say, okay, I will send this code, I will send now the access token, and it somehow proves that is sending the access token, ID token, to the entity that start the whole conversation. In this case, you just do a request and say, okay, I am that person and I need a token. And there is the second sample will be a response with the token. So there is no a middle validation, something that can really authenticate not the user, not the client, but the conversation. It's very similar to the way somehow the HTTPS works behind the scenes when he's negotiating the communication after he gets the certificates. Another thing that didn't exist was the refresh tokens. So, or you create a very short-lived token and you are always requesting a lot of them, or and I saw this in the past in mobile applications, people say, okay, I'll just create a token with a validation for 1 week or 1 month. And again, if you put a longer expiry date here, it means that every log where this token exists are potential source of information that that someone can take and use it against you, because the token will be valid. Okay. And of course, today, I remember, I think it's AWS, I think even the Microsoft ones, when I generate tokens, they can really be quite big. It's not that you have 1,000 characters, it's more than that. And it's very easy to reach the limit of the address in a browser. So there are a lot of issues with this flow, that's why it's deprecated. From the security point of view, from the browser point of view, from the refresh point of view, from the lack of sender constraint, the confused deputy here, there are a lot of issues with this flow, and that's the reason it was deprecated. So the modern alternatives, of course, you can see my previous video, is to use the authorization code flow with PKCE if you don't want to store the client secret in the browser, and you don't, unless you use the backend server to store it and do the negotiation with authorization server. And this is the recommended one because it addresses all the things that you see here are addressed on this modern alternative, and you don't have to be afraid to use it. Even the PKCA, when you are using the browser as the starting point. You don't need or you don't want a backend. Use that intermediary step that I talk about, which is a code verifier that will make sure that who started the conversation, it's the same entity that it's finished the conversation, meaning it's the entity that is receiving the ID token, the access token, and the refresh token. You can receive 3 tokens using this authorization code flow. Why PKCE is better? It provides a proof of possession for the client, linking the initial request, as I was saying, to the token exchange security, even in public client environments, without exchanging the client secret, which is a great thing. So in conclusion, learn from the past, build for the future. The implicit flow was an attempt to simplify token delivery for browser-based applications, and it was really easy. You authenticate and you receive a token, means you can request a lot of times tokens, even if they are short-lived. But remember, all these tokens will be on the address of the browser, and every danger that you can think about using the address of a browser, they will be linked to the token, which means if you have sensible information that can be accessed using the token, it will be sensible information that will be in high risk on your application. Okay, for any new application, special single page application mobile, only use the new one, which is called Authorization Code Flow with PKCE. You can see my previous video with all the details about how to use this flow. So understanding the implicit flow helps appreciate the security advancements in modern OAuth 2 implementations, and I will add to this, it allow you to understand probably current implementations in some projects, how to avoid them, and you can even explain why do you want to avoid, or why the application should upgrade as soon as possible this deprecated flow to the most current one or modern one, which is Authorization Code Flow with PKCE. So this is what I wanted to present. It was a short video compared to the others that I usually do, because it's a very simple flow, but it is really important for you to understand what are the dangers of using this flow. So again, thank you for watching. I hope you like my videos. Share it with your friends, subscribe. It always gives me motivation, and I hope to see you in my next videos.